We are going to be dividing monomials with negative exponents. Negative exponent is just like it seems. The exponent has a negative value. If you don't currently have a calculator, grab one because I want you guys to be able to check some of your answers. Approach these problems. I'm going to show you both ways, and then I'll let you pick. I don't care which way you do it, because there may be one problem that works best this way and another works best that way. So, a negative exponent, that just means the integer is negative. You guys have to be able to add and subtract positive and negative integers with little trouble. So, we learned yesterday that if we're dividing, we do what with the exponents? Subtract them. So that's like 2 top exponent minus, what is the bottom exponent? A negative 4, okay? Top exponent minus bottom exponent is 2 minus a negative 4, which really becomes 6, 2 plus 4. So this is really x to the 6th power. Okay. One way you can always do it is to subtract the exponents with no trouble. I want to show you the other way. When you think of a fraction, I want you to think of it as a 2-story house. In a 2-story house, you have the top floor and you have the bottom floor, right? Top floor and bottom floor. If we have a negative exponent, it's telling you something's wrong. Okay? A negative exponent indicates that we need to change floors. So right now, the x is living on the bottom floor of our house. But it has a negative exponent, so that tells me it needs to change floors to go to the top floor. Okay? So if I rewrite this, I'm going to move this x with the negative exponent to the top floor. I no longer have anything left in my denominator, that's why I didn't write my fraction over. Okay. Now, we're multiplying two variables. When we multiply variables, what do we do with the exponents? That's the first thing we learned, to add them. X to the 6th power. Same answer, isn't it? Okay. I don't care which of these methods you use, you're going to find one that works best for you and go with it. Remember, when we subtract exponent, that variable always goes to the top when we subtract, doesn't it? Let's try another one. We have y to the negative 4 power divided by y to the 3rd power. Let's start with the first method where we're subtracting the exponents. I'm going to take the top exponent minus the bottom exponent. You should be able to do this calculation. What is negative 4 minus 3? Negative 7. So I want you to write it as y to the negative 7. Now we said a little bit ago, when we subtract exponents, that variable always goes to the top, doesn't it? Okay. Now you're not finished if you have a negative exponent. If you have a negative exponent, that tells you that y is living on the incorrect floor. Right now, what floor is that y on? He's on the top floor. He needs to move. He needs to move to the bottom floor of the house. That negative exponent tells me I need to change the floor he's currently on. So he's on the top. I'm going to move him downstairs. Now, when I change floors and move him downstairs, that negative exponent becomes a positive exponent. I have to put something in the top. What's left? Anybody have a guess? It can't be 0. Just say, yeah. It's going to be 1 over y to the 7th. So you've got to think through these problems, don't you? There's not a clear-cut answer always. it the other way. Y to the negative 4 divided by y to the third. So you might at first glance say, all right, that y has a negative exponent. The y in the numerator has a negative exponent, so he's living on the wrong floor. Where should he move to? He should move downstairs, shouldn't he? So in moving, this guy doesn't, this y cubed, he doesn't have a negative exponent, does he? So he stays put, he doesn't have to move. But the y to the negative 4 had a negative exponent, so I moved him downstairs. And of course that negative exponent now is positive. In my denominator I have y cubed times y to the 4th, which is y to the 7th. Same answer. How many of you like the top work better where we're just subtracting the exponents? Anybody like to see where you're changing floors first? You pick what works best for you. And again, there may be times where you use both of these. Look at this one. X to the negative 6 power divided by x to the negative 5 power. Let's start by subtracting. If I take that negative 6 minus a negative 5, what do I end up with? Negative 1. I can never leave a negative exponent in my answer because that means it's just not simplified. So right now x is living on the top floor. He has a negative exponent. Where should he move to? The bottom floor. So when I move x down here to the bottom floor, it looks like that becomes a positive 1. Of course, there's a 1 on top. And you could have written this as 1 over x. Same thing. What if we changed floors first? Both the x in the numerator and the x in the denominator have a negative exponent. So I could have moved the x to the negative 6 down to the denominator, and I could have moved x to the negative 5 up to the numerator, right? They both have negative exponents, they both get to move. Now subtract them. What is 5 minus 6? 5 minus 6 is negative 1. Where's that going to send x? So right here in this step, aren't we? Same place, same place. We're going to move it downstairs. 1 over x to the first power. How about this one? 4 to the negative 3 divided by 4 squared. Now yesterday we had a similar problem. I don't know what the exact problem was. It was 5, I think it was like this, 5, do you guys remember what it was? Was it like 5 to the 5th over 5 to the 2nd? I think that might have been the problem. I saw several of you that wanted to do that, and I want to talk about why we don't divide those 5s real quick. In these previous examples, when I had variables instead of a number as my base, I left my base as x, didn't I? That x didn't go anywhere. We're going to apply the same thing here. The 5 isn't going to go anywhere. It's still going to be 5, base 5 to the third power. 5 minus 2 is 3. Okay. So in the example that we're given, the base is still going to be 4. When I subtract those exponents, what is negative 3 minus 2? Negative 3 minus 2? Negative 5. 4 to the negative 5 power. Now if you typed it into your calculator, go ahead and do that. 4 to the negative 5 power. Did you get the long decimal? Okay. That E negative 4 means scientific notation. I need to move my decimal 4 places to the left. 1, 2, 3, 4. So 0.000976525, etc. Doesn't end there. Okay. So I don't want your answer in scientific notation. Let's think about another way that we could approach that. We have a negative exponent, don't we? That means 4 is living on the wrong floor. He's on the top floor right now. Where could I put it? Downstairs. I'm going to move 4 downstairs. 1 over 4 to the positive 5 power. Now, what is 4 to the positive 5 power? 1024? 1 over 1024. And if you wanted to check that, 1 divided by 1024, that's the same thing as we had right here, isn't it? Okay, but we have an actual fraction answer, which is what we're going to see. Let's try another one. For me, when I'm simplifying these, I choose to subtract. It just makes more sense in my brain. So moving forward, that's what I'm going to do as we simplify these expressions. If you're somebody that wants to change floors, see if you can come up with the same answers as I do. Okay, on number 5, we have 2 to the negative 2 divided by 2 to the negative 4 power. We know we can subtract those exponents. So what is negative 2 minus a negative 4? Positive 2, isn't it? Well, that one we can do in our head. What is 2 squared? 4. Let's do this one next. X squared, y to the negative 3z, divided by x, y to the negative 4, z to the negative 3. Okay, so now we're starting to incorporate multiple variables. The rules still apply, nothing has changed. Let's start with our x's. What is x squared divided by x? X to the first power. Where's x to the first power going to be written? On top. Anytime we subtract, we write that variable on top. So next we have y to the negative 3 divided by y to the negative 4. So that's going to be negative 3 minus a negative 4, which is really y to the first power. Where's y to the first going to go? On top. When we simplify our z's, that's really z to the first. So 1 minus a negative 3 is really z to the fourth power. And again, he's going to go on top as well. All right, we need to add something else in, a new rule real quick. It's a pretty easy one. To help us get started, let's just type something in your calculator. Type in 6 to the 0 power in your calculator, please. 6 caret 0. What is that? It's 1. Type in 1,111 to the 0 power. 1,111. What'd you get? So what if we have negative 2,874.6 to the 0 power? Did you remember to put it in parentheses? Put parentheses around it when you type in your calculator. That's 1. What kind of rule or what kind of assumption could you make with something to the 0 power? It's becoming 1. So what if I said x to the 0 power? Of 1. X is a number, right? We just don't know what number. But it's to the 0 power, so it's going to be 1. So what if I have this? It's 1, isn't it? Because this would be like, I would do power to power. I would multiply those exponents. 1 times 0 would be 0. 1 times 0 is 0. That's going to be 1. That's going to be 1. So 1 times 1 is 1. What if we have this? It's going to be 1, isn't it? These should be your favorite problems. Okay? Anything to the 0 power is 1. It doesn't matter how complicated and ugly it gets in here. If everything is to the 0 power, it's simply 1. Okay? Because remember, x is really going to be a number at some point. You don't know what number it is. Doesn't matter. If we take it to the 0 power, the answer is 1. So, with that in mind, what about this one? It's 1. It looks ugly. I wouldn't really want to start something like this. Doesn't look very nice, does it? However, that 0 out there tells us it's taking the 0 power. It's 1. Okay. It doesn't matter how crazy it gets. Look at this one with me. Go ahead and copy this one down. So in the numerator, we have negative a to the 4th, b to the negative 2, all raised to the 0 power, divided by 5a squared b cubed. Is everything in this problem to the 0 power? Just the top, just the numerator. So if the entire numerator is to the 0 power, what's that entire numerator going to become? Just 1. Is there anything else I need to do to simplify? I don't have any negative exponents, no additional a's or b's, no coefficients to simplify. That's it for that problem. Okay, it looks like I have 3 more examples. I really need you guys to pay attention to these last 3 examples because they're building on the things that we've already learned. Let's look at this one first. So we have parentheses, x squared y to the 4th, all to the 2nd power, divided by x to the negative 2, y to the 3rd, all to the negative 2 power. We have outside exponents, don't we? Okay. We have to take care of exponents before division, according to Pimbus. So let's square everything here in the numerator. So what is x squared squared? Power to power, we would multiply. 2 times 2 is 4. So x to the 4th power. Still in the numerator, y to the 4th squared. Power to power, we would multiply y to the 8th. Now, in the denominator, I have a negative exponent. Who cares? Just deal with it, right? What is negative 2 times negative 2? Positive 4. Y cubed to the negative 2 power. 3 times negative 2? Negative 6. So no big deal if we have a negative exponent. We're just going to deal with it, take it in stride. Alright, so now we're dividing. We can do what with the exponents? Subtract them. Look at these x's though. Aren't they the exact same thing? We talked about this a little bit yesterday. When they're the same thing, what's going to happen? They're going to cancel. So those guys are gone. Those guys are gone. Let's move to our y's. So what is 8 minus a negative 6? 14. So it's going to be y to the 14th power where? top. Anytime we subtract exponents, it always goes to the top. Two more. Do this one next. Negative 3mn squared, all raised to the negative 3 power, divided by 6m to the negative 4 n squared. All right, we have one outside exponent to deal with, right? Let's take care of that first. The first thing that we encounter is negative 3 to the negative 3 power. Type that into your calculator. Parentheses, negative 3, parent negative 3. Get a decimal, don't you? We don't want a decimal. We could change this to a fraction, okay? Or we could just leave this as negative 3 to the negative 3 power. Just leave it for now, okay? Just leave it. I'll show you what to do in a second. So in the numerator, negative 3 to the negative 3 power. M, still in parentheses here, m to the negative 3. N to the negative 6. Denominator is going to stay the same, so I'm just going to bring it across. 6m to the negative 4 n squared. Okay, I'm not going to worry about my coefficients for just a second. Let's go ahead and simplify the m's. Got a fraction going. What is negative 3 minus negative 4? Negative 3 minus a negative 4. M to the first. Where are we going to write that m? On top. Anytime we subtract the exponents, it's going to go on top. N's, we have negative 6 minus 2, which is negative 8. Where's n going to go? On top. Anytime we subtract the exponents, it's going to go on top. N to the negative 8 power. Now, go ahead and write in those coefficients. So negative 3 to the negative 3. I still got 6 in the denominator. Everybody okay so far? I have two negative exponents, don't I? Let's change that negative 3 to the denominator and the n to the denominator. They both have negative exponents. Everything else is going to stay put. So m is going to still stay in the numerator. I had a 6 in the denominator, but now I also have negative 3 cubed. And I also have n to the 8th power. Remember, when you change floors, I moved negative 3 and n downstairs. When I change floors like that, those negative exponents are now positive exponents. Now we just got a clean house. What's negative 3 cubed? Negative 3 times negative 3 times negative 3? Negative 27, right? Negative 27. What's negative 27 times 6? Negative 162. So m divided by negative 162 n to the 8th. Should I change floors with that negative 162? That's a negative number. When do we change floors then? Negative exponent, that's right. Is negative 162 an exponent? No, what do we call that big number? Very good, it's a coefficient. Good job, guys. Leave negative 162 alone, just leave it there. This one I think was hard because of that negative 3. Okay? If your coefficient has a negative exponent, just change floors with it and simplify from there. I think it's easier to think about like that. I've got one more example. I promise this is the last one. For x, y to the negative 3z divided by negative 2 x to the negative 2 y all raised to the negative 4 power. Clearly we have an outside exponent, don't we? Let's take care of that first thing. So everything in the parentheses is going to be taken to the negative 4 power. But numerator, I'll just bring it across. I'm not going to do anything. I'm trying to do one thing at a time. So I have negative 2 to the negative 4 power. If I type it into my calculator, of course using parentheses, right? I'm going to get a decimal, and I don't want that. So just leave it. Just leave it as negative 2 to the negative 4 power. In parentheses. X to what power? Negative 2 times negative 4? 8. X to the 8. And y to the negative 4. I could go ahead and change floors right now. I think I'm going to try to simplify and then change floors here in a second. So I'm going to leave my coefficients. I'm not going to do anything to the 4 or the negative 2 to the 4th power. Just leave those guys alone for a second. It's negative 4. Okay, so on the x's, when I subtract those exponents, I get 1 minus 8, which is negative 7. Where am I going to write x to the negative 7th power? On top. Anytime we subtract, we're going to write those variables on top. X to the negative 7. For the y's, I have negative 3 minus, negative 3 minus negative 4, which is y to the 1st power, so it's going to be on top. And I have the z with nothing else to simplify, so he's going to stay on top also. I have 2 items with negative exponents. What has to happen with those? Change floors. The 4, the y, and the z, those guys are staying put. I'm only moving the x downstairs, and I'm moving that negative 2 to the 4th power upstairs. So 4 is still there. And now I have negative 2 to the positive 4 power. I have a y and a z. In the denominator, I have x to the 7th. Okay, so what is negative 2 to the 4th power? 16. So what's 16 times 4? All right, so real quick, let's wrap this up. If anything is taken to the 0 power, what is it going to become? 1. It's 1. If you have a negative exponent in your final answer, what do we do to make it a positive answer? We just change floors. To make it a positive exponent, we just switch floors. If we had, in this little box here, what if we had negative 3x over y? Does that negative 3 right there tell me I need to change floors? No. What do we call negative 3? It's a coefficient. Coefficients have coefficient rules. It's not an exponent. So just leave it be. All right, today's problems are going to be posted on Google Classroom like they've been the last couple of days. If you don't have internet access, please make sure you copy it down onto your paper.